In this video, let us look at some shortcuts to find the areas of triangles in different cases. First, the area of triangle formed by the lines a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0, a3x plus b3y plus c3 is equal to 0. Suppose you have three lines. If they are not congruent, obviously they'll form a triangle among themselves. Now, what is the area of this triangle? So if you have to physically find the area of this triangle, you first need to find the points of intersections, and from the points of intersections you can use the staircase method to find the area of this triangle. That will be a big process, cumbersome process. So the shortcut to find the area of the triangle formed by three lines is equal to 1 by 2 times capital C1, capital C2, capital C3 times mod of A1, B1, C1, A2, B2, C2, A3, B3, C3 whole square, where A1, B1, C1, A2, B2, C2, A3, B3, C3 are nothing but the coefficients, and capital C1, capital C2, capital C3 are cofactors of small c1, small c2, small c3. So if you take c1, the cofactor is nothing but a2 b3 minus a3 b2. Similarly, the cofactor of c2, a1 b3 minus a3 b1, so on. So you just need to take the numerical value of the cofactor, plus or minus, doesn't really matter. So c1, c2, c3 are values of the numerical values of cofactors of this term c1, c2, c3, and these are nothing but coefficients, determinant, whole square. Next formula is area of triangle formed by the vertices of the form at1 square, 2at1, at2 square, 2at2, at3 square, 2at3 is equal to a square times modulus of t1 minus t2 into t2 minus t3 into t3 minus t1. So you might be wondering what these points are. These points look special, so you'll understand the importance of these points when you read the chapter of parabola. For now, if the points are of this form at square, 2at, with t being t1, t2, t3, the area of the triangle is nothing but a square times t1 minus t2 into t2 minus t3 into t3 minus t1. Next, the area of triangle formed by the line ax plus by plus c is equal to 0 with the coordinate axis is given by half of c square by mod ab. This is a very straightforward formula. If you have the coordinate axis, if you have a line ax plus by plus c is equal to 0, the area formed by this line with the coordinate axis is this triangle. So obviously this is a right angle triangle. The area of this triangle is half times x-intercept times y-intercept. And what is the x-intercept of this? The x-intercept can be found out by putting y is equal to 0, so minus c by a, and y-intercept will be minus c by b. So what is the area of this triangle? Half times this into this is c square by mod ab. Next, area of rhombus formed by the lines which have the equation mod ax plus mod by is equal to mod c is 2c square by mod ab. How do we analyze this? Why does this equation represent a rhombus? So now let us try to analyze this equation. This is an equation involving modulus. So obviously first we need to remove the mod depending on what the signs of x and y are. So in the first quadrant, x and y both are positive. So this equation can be written as mod A times X plus mod B times Y is equal to mod C. This equation in first quadrant looks like this. What is this equation in the second quadrant? So in the second quadrant, X is negative and Y is positive. So mod X is equal to minus X. So this becomes minus mod A times X plus mod B times Y is equal to mod C. And in the third quadrant, both X and Y are negative. So you have minus mod A times X minus mod B times Y is equal to mod C. And in the fourth quadrant, X is positive and Y is negative. So mod Y becomes minus Y. So you get mod A times X minus mod B times Y is equal to mod C. Now, how do we plot these lines? We have already seen how to plot the lines. We just need to find the x-intercept and the y-intercept. So what is the x-intercept? Mod C by mod A. So let us say that this is mod C by mod A, obviously, which is a positive number. And what is the y-intercept? Mod C by mod B. So this is mod C by mod B. Now in the second quadrant, this is the corresponding equation. Now what is the x-intercept of this? Minus of, if you put y is equal to 0, minus of mod C by mod A. So exactly mod C by mod A is this. So minus of mod C by mod A will be exactly the reflection of this. And what is the y-intercept? If you put x is equal to 0, you get mod C by mod B, which is same as this. Similarly, what is the y-intercept of this? Minus mod C by mod B. So now once you have all the intercepts, what is the figure that is formed? In the first quadrant, this is the line which is formed. In the second quadrant, this is the diagram. Third quadrant, this is the diagram. And the fourth quadrant, this is the diagram. Obviously, you can see that you got a rhombus. What is the area of this rhombus? Area of the rhombus is nothing but half times d1 times d2. It is half times, what is the first diagonal? 2 times mod C by mod A. And what is the second diagonal? 2 times mod C by mod B. This 2 and 2 gets cancelled. So 2c square by modulus of AB. So you need to remember this. 2c square by mod AB is the area of this rhombus. Next, we look at the areas of parallelograms. So if you have a parallelogram whose sides are inclined at an angle of theta with each other and whose sides are A and B. So the area of parallelogram is given by base into height. So if this is height, so the area of parallelogram is base times height. That is A times corresponding height. If you take this as the base, the corresponding height. If you take this as the base, you need to take the corresponding height. So base times height. And that is equal to, so this height can be written as B sine theta, because sine theta is equal to h by b, right? Sine theta is equal to, because this angle is 90 degrees, opposite side by hypotenuse. This implies h is equal to b sine theta. So this can be written as AB sine theta. AB sine theta. So the product of two adjacent sides into the sine of angle between them is the area of the parallelogram. This is one formula. So the next formula, if you have two heights with you, if you know h1, if you know the height 1, as well as if you can extend this, you can also find height 2. So this is the distance between these two parallel lines. This is the distance between these two parallel lines. So instead of sides, you know the heights of the parallelogram. Instead of sides, if you know the heights of the parallelogram. So how do we find the area of the parallelogram? So as you have seen, h1 is equal to b sine theta. So obviously h2 by symmetry is A sine theta. H1 is B times sine theta, and H2 is, if this angle is A, if this side is A, this is also A. If this angle is theta, this angle is also equal to theta. So sine theta is H2 by A, so H2 is equal to A sine theta. So this implies what is H1, H2 is equal to AB sine square theta. If you divide both sides by sine theta, H1, H2 by sine theta is equal to AB sine theta, which is same as area. So area can be written as H1, H2 by sine theta. Either the product of two adjacent sides into sine theta or the product of two heights divided by sine theta. Both are same. So these are very simple formulas to find the area. Now the most important formula to find the area is if the sides equations are given. The lengths of sides are not given, the perpendicular heights are also not given. Suppose the equations of these four sides are given. For example, this side is a1x plus b1y plus c1 is equal to 0, and this side is a1x plus b1y plus c2 is equal to 0. These two are parallel sides, so I am taking the same x and y coefficients. Similarly, if these two sides are a2x plus b2y plus d1 is equal to 0, a2x plus b2y plus d2 is equal to 0. So these two are parallel sides, coefficients are d1 and d2. These two are parallel sides again, the coefficients are c1 and c2. Now, what is the area of this parallelogram? So to find this using this formula, you need to find the perpendicular distance between these two parallel lines. The perpendicular distance between these two parallel lines, you get h1 and h2, and you need to find the angle between these two. To find the angle between these two, you need to consider the slopes of these two lines. Once you know the slopes of these two lines, you can find the tan theta between these two, and from tan theta you can find sine theta. So you can substitute in this formula. So you can see that you have a lot of steps. So the shortcut to do this, so area of the parallelogram whose four sides are given is nothing but modulus of c1 minus c2, c1 minus c2, the difference of constants in the first two parallel sides, into d1 minus d2, the difference in the constants of the next two parallel lines, divided by the determinant of the coefficients a1 b1 here and a2 b2 here. So the area is given by the difference between the constants of first two parallel lines into the difference between the constant terms of the next two parallel lines, divided by modulus of the determinant of a 2 by 2 matrix which contains the coefficients a1 b1 and a2 b2. So this will be the direct area for the parallelogram whose four sides are given. It's a very important shortcut, because if you don't know this shortcut, you have to do a lot of things to get to the answer. Thank you.